Apple may have a problem with its next iPhone chip. Let me explain. With a $2.6 trillion market cap, Apple is currently the most valuable public traded company in the world. And when we take a look at the last quarterly earnings, you can see that the iPhone is by far Apple's most important products category, creating the highest revenue. For over a decade now, Apple has released a new iPhone every year in the fall. Sometimes it's in October, sometimes in September, but no matter what, there is a new iPhone every single year. And each year, Apple also upgrades the mobile SoC within. Last year in September, the iPhone 13 got released with a new A16 Bionic, and a year before that we had the iPhone 12 with the A14 Bionic. You don't need to be a genius to realize that this year, in 2022, we will get a new iPhone 14 with an A16 chip. Or will we? Let's talk about it. Starting way back with the A4 in the original iPad and the iPhone 4, Apple began designing their own custom SoCs. But since Apple doesn't own a foundry, they have to work with a manufacturer who can bring their in-house designs onto silicon. From the A4 to the A7, Apple worked with Samsung, but with the A8, Apple started to make the switch to TSMC, as it became obvious that TSMC was offering the best process nodes in the industry. As with every company who designs computer chips, the process node plays a major part in performance, efficiency, and production costs. A great process node can achieve higher clock speeds at a lower power consumption, and a high transistor density means the chip can pack a lot of transistors into a small die size. Of course, it's possible to improve the chip design using the same process node, but it becomes increasingly more difficult. The optimal way to achieve progress is a better design on a better process node, and Apple needs both to keep their advantage. I have talked about both the A14 and the A15 before. The interesting part when comparing these two chips is that both of them are manufactured using TSMC's 5nm process. N5 for the A14 and N5P for the A15. And as such, both chips are very similar. The A15 has many minor improvements and offers more GPU cores, but it's not a huge leap from the already great A14. The biggest issue that arises when you have to design a new chip on a similar node is the transistor density. Apple likes to build wide chips so they can achieve maximum power efficiency by running lower clock speeds on a lot of execution units, which is more efficient compared to using higher clock speeds on a more narrow design. But in order to build wider chips, you need to use a lot more transistors, which in turn increases the die size if you aren't able to use an improved process node with a higher transistor density. And that's where Apple might face a problem with their upcoming A16 chip. As I mentioned, both the A14 and the A15 use variants of TSMC's 5nm process. This year, TSMC is supposed to introduce their new 3nm node, which will be a major step forward. But beginning in the summer of last year, rumors started to surface that TSMC's 3nm process might be delayed. These rumors have since continued. DigiTime reported that the commercial production start for N3 has been postponed to the fourth quarter of 2022, and TSMC also supports these rumors with a capacity increase for their 5nm based N4P process. Now the problem for Apple is that new chips are usually designed with a specific process node in mind. If you followed Intel's long-term 10nm issues, you could see how difficult it is to backport a design onto a process node it wasn't intended for. Before Alder Lake, Intel was stuck using the outdated Skylake architecture because it took way too long to backport their new Cove architecture onto the old 40nm process. And when they finally achieved it with Rocket Lake, it didn't even perform well. Designing a new chip with a new architecture can take years, and if Apple planned the A16 with TSMC's N3 process in mind, it would be really hard to backport it onto a different process node. But if the rumors are true and commercial production is only starting in Q4 of 2022, it would be too late for an iPhone 14 launch in September or October. And because the iPhone is Apple's most important product, it would be a big problem for Apple to delay it. So what are Apple's options right now? There are a couple of different outcomes how Apple could deal with the situation. Number one is the most obvious. They could delay the iPhone launch for a couple of months. Maybe have a limited release in December or early 2023. Yes, it would be a huge delay for Apple as they have always hit their fall release target for the last decade, but if the A16 is designed on TSMC's N3 node and they didn't have the time to react to the delays, Apple might literally have no other choice. For option number 2, we have to consider the possibility that the rumors could be false and TSMC might be able to start their 3nm production in time for an iPhone launch in fall. Maybe the rumors were right in the beginning, but TSMC was able to fix all the issues by now. Also, Apple is by far TSMC's most important customer, so TSMC has big incentives to try their very best. But there are also possible scenarios which do not involve TSMC's 3nm node. TSMC could have told Apple about the delays well in advance, so Apple might have been able to respond by switching the target production node. Possibility number 3 would be a backport to TSMC's N4P process. Again, backports are difficult, they take a lot of engineering time, and it's not a given that the design will perform as expected when realized on an inferior process node. But nonetheless, it's a possibility. The N4P node actually offers pretty decent power efficiency improvements over N5. TSMC claims up to 22%. That's really close to what N3 is supposed to offer with a 30% power reduction compared to N5. But while the increase in power efficiency is not too shabby, the big difference is the transistor density. As N4P is based on an improved 5nm design, transistor density only increases by 6%, whereas N3 is supposed to offer a whopping 70% gain in logic transistor density. With the A16 Bionic, Apple already increased the die size quite a bit. While the A14 only used 88mm squared, the A15 increased it to about 112mm squared, and the A15 was designed with TSMC's N5P process in mind, thus Apple knew not to push the transistor count too much. With a 3nm target node that offers up to 70% increase in logic density, there's a good chance the A16 design is using a lot more transistor. A backport to N4P would blow up the die size quite a bit. I think this is the least likely option here, but I wouldn't rule it out completely. This brings me to the last solution, which is more of a quick fix. Apple could shrink the A15 chip using the N4P process node, change the name to A16 or A15S and call it a day. With increased power efficiency, they could clock the chip a bit higher without hurting power draw and still offer a slightly faster chip. The performance gains from the A14 to the A15 wasn't that big, and with another small performance increase this year, it's entirely possible. And it's not like these chips are slow in any way. The iPhone 14 with a 4nm A15 would still be plenty fast. That also means the real A16 would be delayed to next year, maybe being introduced in another product first, like an iPad. But it would also throw a wrench into Apple's SoC roadmap, as the A17 for next year is already well into its development. So there you have it, my take on the rumors about TSMC's 3nm delays and the possible implications for Apple. We could see a new A16 chip on TSMC's N3 process in the fall if the delay rumors turn out to be wrong. We could see the iPhone 14 getting delayed if the rumors are true and Apple wasn't able to adapt. A backport of the A16 to N4P is also a possibility, as is the possible shrink of the A15 to the N4P node. In my opinion, the delay rumors have been too persistent to be just a fluke, and TSMC's focus on more N4P production capacity and rumors about a N3B process definitely tell a story. Out of the 4 different scenarios, I think a iPhone 14 delay or the release with an A15 shrink to N4P are the most likely. But of course, this is pure speculation on my side. The A16 backport just seems like too much of a stretch to me. In any case, there's a very high chance that Apple has to adapt their plans for this year's iPhone somehow. I'm confident Apple has chosen the best possible option, and I'm looking forward to see how the situation will actually turn out. I would also like to hear your opinion. Do you think Apple will delay the iPhone for the first time in over a decade? Do you think the rumors about the 3nm delay might be wrong? Or are you expecting Apple to work with TSMC's N4P process, either using a A16 backport or a A15 shrink? Or maybe I missed another option? Leave me a comment down below and let me know what you think. As always, if you enjoyed this video, please give it a thumbs up, subscribe for more content, and see you in the next video.